Magnetic field. A magnetic field surrounds a magnetic substance, making up a permanent magnet. In addition to containing an electric field, the region of space surrounding any move electric charge also contain a magnetic field. When charges are not moving, no much effect is seen. Magnetic field is represented by magnetic introduction. Moving, no such effect is seen. We see define a magnetic field B at some point in space in terms of the magnetic field force F that the field exert on a test subject, for which we use a charge of particular moving with a velocity v. The relationship between magnetic and electricity was discovered in 1819 during a lecture demonstration. Hans Christian Ørsted found that electric current in a wire deflected a nearby compass needle. There is a steady current, the demonstration of magnetic field produced by the current in a wave. We can perform experiment simple using a apparatus similar to the down one down or set. We able to demonstrate a connection between magnetism and electricity by applying current of a wire. In 1806, Hans Christian Ørsted became a professor at the University of Copenhagen, where his first physical research did the electric current and acoustic. In 1932, the name Ørsted was adopted for the physics unit the magnetic field substances. When current is passed through a long wire with compass needle placed around it in a circle, compass needle line up the magnetic field. Similar observation can be made through a cardboard on which iron filling are springed. These, these iron filling from concentric circle around the wire, as shown in figure. These experiments show the orientation of a magnetic field, which is a form of circle around the wire. The direction of magnetic field can be determined by the experiment of magnetic field is defined by that circle of the state. Force in a current carrying conductor. When a current carrying wire is placed in uniform magnetic field, the magnetic field of the wire is exerted uniform magnetic interest, resulting in a force on a wire as shown in figure 13.4. The force FB depends on the magnetic field B, applied current in a wire, and the length L of the wire that used in a field, and sense of the angle theta that the current carrying wire make with the field. When a current carrying wire is placed in a uniform magnetic field, the magnetic field of a wire external uniform field interest, resulting in a wire on the wire as shown in figure. The force FB depends on the magnetic field B applied. Current in a wire in a length L on a wire and the field. The sign of angle theta the current carrying wire make with the field. A magnetic field surrounded a magnetic substance making up a permanent magnet. In addition to containing an electric field, the region of space surrounding and moving electric charge also contain a magnetic field. So that we have to contain in which we use a charge of particular moving with velocity v. The relation between magnetic and electricity was discovered in 1819 during a lecture demonstration. Hans Charles Ørsted found the electric current of the wire reflected in the state of electricity. The direction of magnetic field B on a wire can be determined by right hand rules, Fleming left hand rules as shown in figure 13.6 and 7 respectively. The magnetic introduction B 1 testa of 1 million long wire carrying a current as if A are placed perpendicular to each other and the force between them 1 N and SI Outstretch finger up right handed in the direction of current, then bend and finger in the direction of magnetic field. Set the thumb in the first two fingers of the left hand at right angle to each other as shown in the figure as the first finger pointing to the direction of the field, second finger pointing in the direction of current. The thumb will give the direction of the force. A wire carrying to a current and has length of 10 cm between the poles of the magnetic is kept at the angle of 13 degree. The uniform field of 0.60 which the force acting on the wire, in which we show about the magnetic flux. The scalar product of magnetic field B and the area A is magnetic flux. Magnetic introduction tell us how close together magnetic field lines are, as it tells us the strength of the magnetic field. The number of magnetic field lines passing through a surface placed perpendicular, it's called magnetic flux. Magnetic flux. If area vector A is parallel to the magnetic field B, the magnetic number of magnetic field line will pass through the surface. Therefore, magnetic flux will be maximum. Magnetic flux. If area vector A is perpendicular to the magnetic field B, there no magnetic field will pass through the surface. Therefore, magnetic flux will be zero or minimum. Ampere current law giving us Andrew Mary Peter Ampere in 1826 related the integrated magnetic field in the loop around current wire to the current passing through a wire.